Physical activity interventions are widely used to promote health and performance. In most of studies, moderate to vigorous intensity of physical activity has been advocated. Yet, few studies have examined the dose response at the low end of the intensity range. In other words, if individuals increase the light intensity of physical activity or decrease the sedentary behaviors, would this lead to health benefits? It's examined the associations of objectively measured sedentary time, light intensity physical activity, and moderate to vigorous intensity activity with fasting and 2-hour post-challenge plasma glucose in Australian adults. A total of 67 men and 106 women, mean age 53.3 years, without diagnosed diabetes were recruited from the 2004 to 2005 Australian Diabetes, Obesity, and Lifestyle Study. Physical activity was measured by actigraph accelerometers worn during waking hours for 7 consecutive days and summarized as sedentary time, light intensity, and moderate to vigorous intensity. An oral glucose tolerance test was used to ascertain 2-hour plasma glucose and fasting plasma glucose. After adjustment for confounders including waist circumference, sedentary time was positively associated with 2-hour plasma glucose. Light intensity activity time and moderate to vigorous intensity activity time were negatively associated. Light intensity activity remains significantly associated with 2H plasma glucose following further adjustment for moderate to vigorous intensity activity. Associations of all activity measures with fasting plasma glucose were non-significant. These data provide the first objective evidence that light intensity physical activity is beneficially associated with blood glucose and that sedentary time is unfavorably associated with blood glucose. These objective data support previous findings from studies using self-report measures, and suggest that substituting light intensity activity for television viewing or other sedentary time may be a practical and achievable preventive strategy to reduce the risk of type 2 diabetes and cardiovascular disease. When comparing vigorous intensity physical activity and moderate intensity physical activity, 2 problems to be concerned about. Confounding by volume of physical activity issue 1, and confounding by activities of other intensities issue 2. Issue 1. If we observe stronger associations with vigorous physical activity, is this due to the intensity per SE, or is it because vigorous physical activity simply expends more total energy? Issue 2. If we observe stronger associations with vigorous physical activity, is this due to the intensity per SE? Or is it because persons doing vigorous physical activity also do more moderate and light physical activity? Directions. Particularly in the last decade, we have learned a lot regarding dose-response relations between physical activity and health. But there still remain gaps in knowledge. Today, we used case studies to understand gaps and to explore ways to add to knowledge. This will hopefully stimulate new studies to inform future physical activity guidelines. People off their fatty acids, there are some research questions that warrant future investigation. For example, what dose of non-sitting will produce a meaningful lowering of clinical events? What data can I use to set a target of reduced sitting time for a dose-response study that will likely contribute to a reduction in mortality? Although moderate to vigorous physical activity is related to premature mortality, the relationship between sedentary behaviors and mortality has not been fully explored and may represent a different paradigm than that associated with lack of exercise. Kaczmarzyk and colleagues examined the relationships between time spent sitting and all-cause mortality. In particular, the researchers prospectively examined sitting time and mortality in a representative sample of 17,013 Canadians 18 to 90 years of age. Evaluation of daily sitting time: almost none of the time, 1/4 of the time, half of the time, 3/4 of the time, almost all of the time. Leisure time: physical activity, smoking status, and alcohol consumption was conducted at baseline. Participants were followed prospectively for an average of 12.0 years for the ascertainment of mortality status. There were 1,832 deaths, 759 of cardiovascular disease and 547 of cancer during 204,732 person-year of follow-up. After adjustment for potential confounders, there was a progressively higher risk of mortality across higher levels of sitting time from all causes and cardiovascular diseases but not cancer. Similar results were obtained when stratified by sex, age, smoking status, and body mass index. Age-adjusted all-cause mortality rates per 10,000 person-year of follow-up were 87, 86, 105, 130, and 161 in physically inactive participants and 75, 69, 76, 98. 105 in active participants across sitting time categories. The researchers concluded that these data demonstrate a dose-response association between sitting time and mortality from all causes and cardiovascular diseases, independent of leisure time physical activity. In addition to the promotion of moderate to vigorous physical activity and a healthy weight, physicians should discourage sitting for extended periods. In terms of the relationship between sitting or sedentary behavior and health outcomes, research evidence shows that higher amounts of sedentary behavior sitting is associated with increased risk for various diabetes and cardiovascular disease biomarkers and all-cause and cardiovascular disease mortality. This increased risk appears to be somewhat independent of time spent in moderate vigorous physical activity. Also, longer bouts of sitting time are associated with increased risk and more frequent breaks appear to decrease risk. High amounts of sedentary behavior carry greater risk in men and women who perform little or no moderate vigorous physical activity compared to those who meet moderate vigorous physical activity. Guidelines. So far, it looks like sitting time needs to be decreased by hours per day to achieve a significant decrease in risk. The followings are what we don't know about modifying the risks of sitting. Does sitting confer special health risks beyond it being a good indicator of light intensity activity? Should sitting be considered a separate behavior or be considered a component of a continuum of inactivity, activity? Does just standing, for example, using a standing desk compared with sitting in a chair, reduce risk of chronic disease? If so, what profile of standing needs to be implemented? How long or short should the bouts of sitting be, and how frequent should standing breaks be taken, and how long should these breaks be? Does moving legs and/or arms while sitting reduce the risk of chronic disease, or is getting out of the chair necessary? Would using some type of rocking chair negate some of the risk caused by stationary sitting? What are the health risks/benefits of lying or reclining versus sitting? How beneficial is it to reduce sitting during the day if you meet upper end of MVPA guidelines 300 minutes/week?